to our channel. We are doing the second part of this video, the configuration of Hall effect into your pulse motor system. So from this diagram, we are now trying to show you what it takes and how to connect it to your real life circuit. So as you can see from this flywheel, we have north and south poles of magnets attached to this flywheel. Now this is the starter coil, and here are the two connections, the two leads. Then now I want to show you something. This is the Hall effect switch. So whenever this switch approaches this face of magnet, this light here comes on, and at that time this starter coil should be energized. Then you now ask yourself, how do you now know the direction of this starter coil flux flow? How do you determine the configuration so that when they are aligned this way, it will repel the magnet facing this starter? How? Assuming this is a north pole, this south, your starter coil should also be faced with a north pole. That means the south should be in between. That means your Hall effect switch must be facing a north pole. Then your starter coil should also face a north pole. Then look at the two terminals, two wires coming from the starter coil. Now there's something we have to do here. Let's take away this, try to energize it separately. These are the two coils. Okay, let's do this testing now. This is the starting of the coil, the 0. Then we connect one of the terminals. Then let's get this is the second lead, the finishing side of it. We connect it to the positive line. Then let's use this charged capacitor circuit bank to determine which pole or how to connect it in a way so that it will repel the magnet there. So let's hook the negative is. So the reaction, it seems the reaction there. Okay, so from the video you see, you can test to know, yeah. So it is a bit repulsive. You make sure it repels the system. So if you connect it wrongly, it will attract the magnet. So here it is repelling, that's trying to push it off. Because of the other coil here, that is why it's not moving. So you can see the repulsive force. So now we try to connect this whole setup. We've gotten what we want. That means this one, now the leg, one of the terminals from this diagram, the terminals which is the drain of the MOSFET should now go to the ending point, the end point of your starter coil, which is this. That's the positive terminal. Then the negative of your battery from this diagram goes to the ending point of the coil. which is that terminal we connected the negative. So this should be the point that will go to the negative of the battery. Okay, goes to the negative of the battery. Let's off that. Then from this system, what we have here, we now have the reactive charge collectors, the two terminals. Then from the negative part, the wire that goes to the negative now will be connected to a rectifier, which is this diode you are seeing here from this diagram, the diagram, which is this. So we connect our positive terminal of the charger to this cap to charge it on the negative. Then the other lead, which is the positive terminal, which is here, now goes to the negative of the charging battery, which happens to be this one. So from this configuration, we are done. We can now connect the negative terminal to the battery to see how this responds to charge. Now it is not on until you give it a notch. So this is why we call it a pulse motor, that whenever, so you can see it is on, never mind the vibration. So whenever this is aligned to the North Pole, at that same time this one will be triggered or in a repulsive mode. It is moving this way because of the size of the copper we are using, and also the number of turns in this starter coil. This starter coil should operate with a voltage up to 48 volts. If we want to make effective use of the turns we use there, but this is for experimental purpose to show you how the configuration is done. So here, this one is moving. You can as well adjust the speed. The position of the Hall effect can either increase the speed of the system or decrease it. So this is a gradual movement showing you that actually it is this part of the system that is on. The other side is not being utilized. So this diagram again, your Hall effect, which is this, as we said, the first leg of the Hall effect, when you see the number facing you, is the positive, connected through 1K to your battery. Then the second one happens to be the negative, connected straight to the battery. Then from there you connect a terminal down to the negative, which is the starting point of your copper wire, the winding. So at that point, the next one is the configuration of this MOSFET. The signal, since it is a negative signal, you connect it through the 1K resistor, which is down here, 1K resistor, to the leg of the gate of the MOSFET. The first leg, when the MOSFET is like this, the first is the gate, the second is the drain, the last one is the source. So through the diagram you can see this leg is connected through 1K to the gate. Then there is a bypass from the source to the same gate. Is where we connected this 100K. So the 100K is here, the two final legs and the starting, which is the drain, the gate and the source. Then back to the source, we have the positive line, the positive wire coming from the battery is connected to the source because it is a P-channel MOSFET. That means positive current will pass through the MOSFET. Now the positive current passes through the source. Then it will now continue because of the configuration of this MOSFET. You know that the body, the iron part of it is the drain. Then since it is attached to a heat sink, you now connect any wire from any of the holes, which you will use a screw to hold the wires, then down to the other parts of your starter coil. Now from the starter coil, you must not forget this. A P-channel MOSFET, this MOSFET is very fragile, that if you don't connect your feedback battery, that's the battery that will take care of the back EMF, you will end up losing this MOSFET. The current from the back EMF will automatically damage this MOSFET. That means you have to make sure that this back EMF is taken proper care of. That means you must connect it to a feedback a battery that will handle that. So you can see it is moving. So there are other things we need to add to this, but to make it shorter and as brief as possible, this is where we'll end today's tutorial on the Hall effect connection. How to connect your Hall effect to a pulse motor system. If you have any comments or questions, you can reach us on any of our YouTube, from our YouTube channel or Facebook or through WhatsApp. Jeff Green Energy Concept. We are here to solve this problem and to make sure you understand the A to Z of this pulse motor system. Thank you as we proceed in our next video. If you find this video interesting or helpful, do not forget to subscribe, to follow us, and to be in touch, so that as we march to the road of free energy freedom, you will be part of this success story. Thank you.